All right, so it's lesson 5.3, logarithmic and exponential forms or functions. Okay, so remember on this first one, saying to let the function equal log base 2. Remember the little number, you call it the base. Okay, that number right there, we call that the a, and then this would be the e. Okay, so we're going to rewrite the equation so it starts with x equals that number, or x equals. So basically, we're going to do this in a different form. Okay, so what we want to do is, first of all, keep in mind that y equals, and actually, let's actually write it with different words, different letters. E equals log of the base a. Okay, so that's the log form. So if I change this into exponential form, my base is the number I write first, and then the e becomes the exponent of that base, and you make it equal to the variable a. Okay, so let's change that and put it in that form. So we're starting with log y equals log base 2 of x. So my base is 2. My exponent is y. And then it's set equal to x. Okay. So once I have this in this form, okay, now this obviously looks different than this equation, but you got to remember that they are the same. These are equal. It's just a different way of writing that, different way to help you write it to solve other types of problems. Okay, because sometimes you don't know what the base is, sometimes you don't know what the exponent is. This allows us to kind of put it in different forms so that we can solve the equations that are going to be coming up next. Okay, so are they the same? No, they're not. They don't look the same. Okay, do they mean the same? Do they mean the same thing? Yes. In other words, they're equal. Okay, and are they equivalent? Well, we can double check to see if they're equivalent by graphing them. Campus is now closed. All right, so I'm going to type in y equals log. Oh, and I forgot. Log, you actually need a special option here in Desmos. So I go to functions, and then go to miscellaneous, and then right here you'll see the log with the little a down there. That allows you to type the base. There's the log base 2 of x, and then let's type 2 raised to the exponent y equals x. As you notice, they literally are the same function. Okay, so it's just a different form. All right. Okay, so now the next problem is basically taking all these different forms and just changing it to the other way. So here, if I start with y equals 3 to the x, well, again, I write log base 3, because 3 is my base. And then of a is this number, is this variable over here, so y, and that equals the exponent, so equals x. Okay, here, if I start with log, I'm going to first write my base, which is 5, raised to the exponent y. Okay, that's equal to the a x. Okay, now this one, 1/3 is my base. And put that in parentheses. And so the exponent, again, it's going to be the capital P, and that's equal to your a, which is the m in this case. Okay, so if I'm working on these, it's pretty much the same thing. It's just you're putting variables instead of numbers. All right. Okay, now this one, if x is equal to 7 to the y, how would you write this equation in y equals form? So in other words, you're just basically doing the exact same thing you guys did here and follow the same steps. Okay, so it's almost like that one there. Again, just remember that you have b. This is in the exponential form, so b to the e, which is this part, equal to a, which is the x, and then just change this to log base b of a equals e. And you just switch those different parts of the equation around. Okay, so now on these ones down here, you're actually solving some equations. Okay, you want to do these without a calculator. Okay, and they're once you kind of understand how to change the equations, you should have no problem doing this without a calculator. All right, so remember, this is my base. So I'm going to, basically, if it's in log form, I'm going to change it back to exponential, which is all of these. They're all in log form. So there's my base, x to the 1 exponent equals 20. Well, x to the 1 is the same thing as x, so literally it's just x equals 20. Okay, here, base is 5, the exponent's x, and then it's equal to 25. Okay, well, they're not the same base, so what I'll do is I know that 25 is the same as 5 squared. And now notice they're both the same base, so that means that x equals 2. So in other words, you really, what this equation says is, what power do I raise 5 to get it to equal 25? It's 2. All right, so now this one, that's a 9, so 9 squared, 9 to the 2 equals x. And what would that be? X equals 81. Okay, so now 5 to the 1/2 now equals x. Now, if you guys remember rational exponents from the last lesson, if I have 1 over 2, I could change this to radical form and put it basically the little root symbol on it. And that 2 goes here. And remember, if it's a square root, I don't have to put the 2. And this is just a 1. So basically, x equals the square root of 5. Okay, now this one, we got x down here. So x to the power of 4 equals 16. And then I got to figure out, well, what number do I raise to the power of 4 to get to 16? Well, if you're not really sure what the number is, you can always just factor this out, maybe like with the birthday cake. I'm going to divide the smallest number possible. I'm going to start with that, so that'd be 2. Divide by 2, divide by 2, divide by 2. And notice how I get 1, 2, 3, 4 2's. So that means that this 2 to the 4, oh, sorry, that's not how I wanted to write it. X to the 4th equals 2 to the 4th. So I know that this must be 2. So x equals 2. Okay? Now this one, 10, move this over a little bit, 10 to the x, so base to the e equals your a. And so now basically what power of 10 is equal to 1,000? Well, 10 to the 1 is 10. 10 squared is 100. So 10 cubed would be 1,000. So that means that this, basically 10 cubed, is equal to 10 to the x, which means x equals 3. So that's the power we're looking for. So a lot of times you notice that you're looking for a power, like what power do I raise a number to get it to equal that value? Or what would the base be? And what if it was raised to a certain power, how do I get it to equal this one? So you're kind of thinking through, or maybe you have to factor it out in order to figure out what that missing unknown is. Okay, so let's go to the next page. So now here, same thing. We're going to use the same kind of definition and change the form here. So 16 to the x equals 32. And just remember, guys, I'm doing my own problems here, so use these examples to complete yours. And I don't really know right off top, like, what I could change the base to. So what I'm going to do is I'm going to birthday cake both numbers or factor them out. Now, 16, we just literally did that on the other page right before this, right? So if I did that, I get 2, 2, 2 as I kind of do the birthday cake method with that. So that means that 2 to the 4, and remember the new exponent you just multiply. So now it's 4 times x. And I do the same thing with 32 now. Okay, I'm going to factor that out, divide by 2, that's 16, divide by 2. And notice that I pretty much end up with the same numbers again. Divide by 2, divide by 2, divide by 2. 1, 2, 3, 4, 5 2's. 2 to the power of 5 is equal to 32. So 2 to the power of 5. All right, now that they have the same base, they're both 2. That means these exponents must be equal, so I set them equal to each other. So 4x equals 5, and now I just solve for that. So I divide by 4, divide by 4, and x equals 5 over 4. Okay, so that basically says that if I raise 16 to the power of to the power of 5 over 4, it would equal 32, or 5/4. Okay, same thing here. 27 to the 1/3. Raise the base to this. Oops, I'm sorry, I forgot the x in here, didn't I? Okay, 27 to the 1 over 3 equals x. And now irrational exponents, I always want to think, okay, to solve that, I want to put it back in the radical form, like on the last page. Okay, so that means the index, that number goes here. That's the number on the bottom, the 3. And then the 27 goes in here. So really what this is the cube root of 27. So what number would you multiply 3 times to get 27? Well, if you're not sure, you could just birthday cake, factor it out. Now, some of you guys might know the answer to this, but let's say you got a number that you don't know, okay? So I'll start with the smallest number I can divide. Well, 2 is not going to work, so let's try 3. Divide by 3, that's 9. Divide by 3, that's 3. Divide by 3 again, that's 1. So I get 3 3s. Well, there's 3. So 3 times 3 times 3. That means x equals 3. All right, and again, yes, I could take out the calculator or Desmos and figure out the cube root of 27. But again, these are things I want you to kind of get familiar with. What would be the cube root of 27 or 64 or 81? Start getting familiar with those things. Or just use this method to kind of break it down. That way you can see it, okay? All right, so now here, same thing. So 4, base 4, exponents x, and then the a is 4 to the 5th. Notice they're already the same base, so I don't have to do anything. So that means that x equals 5. Okay, now this one, I know it looks like it's in log form, but notice how the log is literally in the exponent. Sorry, hang on, get rid of this. The log is in the exponent. So it's actually an exponential form. That 10 is your base, the log part of it is the e, and the x is the a. So actually, we're going to go reverse. Now we're going to go back the other way, back into log form. Okay, so this is the base of 5. So it's going to be log base 5 of the a, which is going to be x. And then this log, the exponent, will be set on the other side. Now, what I want you to notice is that they have the same base, log of 5, or log base 5. If you have the same log on both sides, and they're both the same base, these basically cancel out. So that must mean that these are equal, x equals 3. Okay, so now here, again, we're very much following the same steps as before. Okay, so now 81 to the power of x equals 3. So what would be the power, or what number would we divide this down to, or factor it down to, so they have the same base of 3? Okay, well, let's do that. Let's do the birthday cake over here. So divide by 3, I get 27. Divide by 3, I get 9. Divide by 3 again, I get 3. Because again, when you get these types of problems where you got 2 numbers on each side and they don't have the same base, we want to change the number somehow so that it gets to be the same base, and then we can just cancel things out. Okay, so now this is 4 3, so this is equal to 3 to the 4, and that x, I just multiply it, so it becomes 4x. Now, what about the other 3? What's the exponent here? Well, if it's just a 3 by itself, it's 3 to the 1. Okay, so now we have the same base, and 4x equals 1, and then we just divide by 4. Okay, now this one, I'll help you set it up. I want you to solve it on your own. X to the power of 0 is equal to 1. What number could go there and make that true? All right, you figure that out. Message me or email me if you want help on that one. Okay, so now this one, base of 7 to the power of 21 equal to x. Now that's going to be a ridiculously huge number. I don't want to write all those numbers out. Okay, so when you get to numbers that big, the 21st power, I mean, I don't even know. It's probably more than a trillion. Okay, so we'll just leave it like that. There's no need for us to go any further. Okay, now this one's very similar to that one up here where I had logs on both sides. Remember, when you don't write the little base number in there, it's automatically a 10. So every log always comes in a base of 10 unless it's written there. So these have the same base. That means that 11 is equal to 3x minus 1. So I can just set it up like an equation. 11 equals 3x minus 1. Now I just solve that. Add 1 both sides equals 12. Divide by 3. X equals 4. Okay, same thing over here. Logs are the same. I'm going to set this up over here just to give myself a little bit more room. And now 3x squared minus 8x minus 40. That's equal to 20. Now notice I have a square term in there, which means I'm about to solve it like a quadratic. I'm going to factor it, make it equal to 0. So here, subtract 20 from both sides. 0 equals 3x minus 8x minus 60. Okay, so now I want to factor this out. What I'm going to do is I'm going to pull up the x over here. See, negative 60 times 3 is going to be negative 180x squared. And then negative 8x goes up here on the bottom. Okay, so now I want to figure out what two numbers multiply to 180 but add up to negative 8. And some of you are going like, whoa, that's a big number. Like, how do we figure that out? Like, I'm good when it's just like 8 and 7, but like, how do I figure out 180? Well, you just kind of have to like go one number at a time. So I'm literally going to start with 1. So if you got a calculator on hand, phone, Desmos, I'm literally just going to start this. Okay. Okay. So, sorry about that. Technical difficulties. All right. So I'm going to start by figuring out what numbers will divide into 180. That will basically help me find the combination of numbers that are going to work for this. And just know that those numbers, right, they have to like add, or most likely in this case, since there's like two negatives here, they're going to have to subtract two numbers, right, to get it to be negative 8. So let's start with 1 times 80. Why not? Or 1 times 180, right? Or 2 times what equals 180? Well, that'd be 90. Okay, now 2 and 90, that's nowhere near making that work, right? So I'm not gonna go to 3 or 4. I'm gonna go up a little higher. I'm gonna go to 6. Okay, so let's say 180 divided by 6. Okay, that's 30. So that means that 6 times 30 is 180. Are those anywhere near to being close to 8? No, not really. All right, so how about 10? Let's try 10. Okay, so 180 divided by 10. Okay, it's 18. Now, if I subtract those two, will I get 8? Hey, there it is. Those are the two. Now, along the way, you may have tried 8. Maybe you tried 9. Like, that would work too, right? Like, if I put 9 times 20, okay, but that still doesn't add up, or that still doesn't subtract and give me 8. Or you could have tried 8 itself, divided by 8. Okay, oh, 8 didn't work, even though it's 180. All right, so again, guys, you just kind of go one number at a time and keep dividing until you get there. All right, so we know it's 10 and 18. Now, in order to be negative 8, that means the bigger number's got to be negative 8. Okay, and now remember now that I've got a 3 in the front, so I got to do the box too. I got to basically do the whole deal here. Let me set up my box over here. Actually, I'll do the box over here where I got some more space here. I'm not on piling stuff on top. So first term, first box, last term, last box, and then your two numbers you discovered. Okay? Now, the way I like to do this is I pick either the column or the row to figure out what goes here. Now I know it's 3x times x, but where does the 3 go? Does the 3 go on top or on the left? Okay, so you do that by looking at, all right, 10 and 3, do they have a common factor or common number that you can divide into? No, just one. So I know that only x goes here, which means that 3x must go there. And if you look at 18 and 3, they both can be divided by 3. So I know the 3x goes there. So now 3x times what will give me negative 18? Well, that would be negative 6. Okay. And then how about up here? X times what will give me 10? That'll be just 10. Okay. So now, let's bring this over here. So now I have 3x. Now it's plus 10. And then x minus 6. Okay, so now the x minus 6 is the easy one. It's just the opposite of the sign. X equals positive 6. But 3x plus 10, not so easy. So I'm going to set that up as 3x plus 10 equals 0, and I'm going to solve that. So minus 10 minus 10, this equals negative 10, 3x equals negative 10, and then divide by 3, and you can see right there, there's my answer. X equals negative 10 over 3. Okay, so now with that, shortcut is if it's positive, it'll be negative, and that number goes on top while the number in the front of the x goes on the bottom. Okay, if you want a shortcut on how to figure those out. Okay, so solve each equation to the nearest thousandth. So as soon as I hear that, to the nearest thousandth, that means calculator time. I'm going to use a calculator. All right, so here, let's set this up in log form since it's in exponential form and that x is in the exponent. So to get it out of the exponent, I'm going to put it in log form. So log base 3 of 14 equals x. So basically, I plug in log base 3 and 14, and that's going to give me the solution. All right, so here, again, I need that base. So I'm going to click function, move my head out of the way. And I need this one so I can change the base. So log base 3, 14. All right, so 2 points. So remember, to the nearest thousandth. So 402, there's the thousandth. I look to the right, it's a 1, so it's just 2.402. Okay. All right, now this one looks like I could divide this both sides by 4 first before I do anything. Okay, so then x to the 4th equals 8. Okay, so now, how do I do that? Well, I'm sorry, you guys couldn't see that, could you? I divided both sides by 4. All right, well, if it was, let's just say something was x squared, right? Like x squared equals 25. What would you guys do? You would square root both sides, right? All right, so anyways, if it's this problem, I do the same thing, except I take the 4th root of both sides. So this is a little different than the log stuff, but more kind of a review slash, dealing with exponents and how to solve them. Okay, so if I take the 4th root, that just becomes x. But now I got to find the 4th root of 8. Now, calculators can do this, but I think the easiest one for you guys, especially at home, is to use Desmos. Okay, so if I go here, you'll see the square roots down here at the bottom. But if I want the root with like the little letter or the number, I click on this one right there. That has the n. So I put the 4 and then the 8. What number do I multiply 4 times to get to 8? 1.681. I look right there, it's a 7, so that'll become 682. Okay, so 1.682. All right, now this one. Kind of like this one, you had a number in the front, right? So we could divide that off first. Divide by 3. And now I have 2 raised to the power of x minus 1 equals 11. All right, well, now that x is in the exponent like it was in this one, so to get it out of the exponent, put it in log form. So log base of 2, the a is 11, and then your e goes here on this side, which is x minus 1. Okay, so I can plug that in the calculator, but I need x to be by itself, so I'm going to have to take the log base of 2 to the 11 and then add 1 to both sides. So what this looks like is log base 2 of 11. I do that, and then I add 1. Okay, so make sure you do this separately. All right, so when I plug this in up here, you get the log base function. There it is, 2, 11, and go outside the in parentheses and put plus 1. Okay, so let's see, we got here 4.459. That 4 doesn't change the 9, so it's 459. So x equals 4.459. Okay, last one. Now it's in log form, and the x is in the a. So because it's in the a, we can get it out of the a by putting an exponential form. So the base is 4. The e over here is -2. And then the a becomes your answer over here. All right. Now, remember when you have a negative exponent, we can change it into a positive exponent by bringing it down to the denominator. So this basically becomes 1 over 4 squared, a positive 4 squared. Okay, equal to x plus 2. And now I'm going to do 2 things here. First thing I'm going to do is I'm going to subtract 2 from this side so I can get x by itself. Okay? All right, so that's -2 there. I'm kind of adding it in so you don't get confused. I'm not subtracting 4 minus 2. All right, so 4 squared, that would be 16. So now it's 1 over 16 minus 2. Now, I need to figure out what that is. I do this a couple ways. I can change the fraction, or I can use Desmos. First, I'm going to show you how to do it on paper. Most of you guys should know how to do this now. I take my whole number, put it over 1, common denominator in order to add and subtract. So I multiply both the top and the bottom by 16. So I get 32 here over 16. So now it's just 1 minus 32. And 1 minus 32 is -31 over 16. Okay, the other way to do this would be go into Desmos here. 1 divided by 16 minus 2. And it gives you this decimal. You can click on that, and boom, it gives you the fraction. Okay, so that's another way you can figure those out. Okay, that is it. Beautiful.